Hi and welcome to Wave 2019. I'm Daniel Bogdanoff, streaming live from Colorado Springs, and we are so excited that Wave is finally here. If you've been with us over the last couple years for Wave last year and Scope Month on years before, you know that there's a rich tradition of having technical difficulties on the first day's live stream, and you know we're fond of tradition around here, so we thought, thank you for coming to the new stream. We don't know, technical difficulties, but we'll get it fixed on our next live streams. We're live streaming on Monday, the following Monday, and then March 15th, the last day. But before we get rolling on today's stream, make sure you go register for the event at wavekeysight.com. That's how you enter the daily giveaways and get access to the Wave exclusive library, which is full of handpicked ebooks, white papers, and app notes. Go sign up now and you'll be entered into the drawing happening later in this live stream. You'll get access to those libraries, and you'll be entered into all the daily drawings for the rest of the event. Also, make sure to stick around until the end. We have some of our eminently patient R&D folks who are in this room, and they're waiting to come out at the end of the stream for a panel Q&A. So put your questions in chat if you have any questions. We have people from the ASIC design team, from the Scopes R&D team, and then some from Brig, AC from the podcast that you might recognize, and then a couple other surprises for you. In today's live stream, we're going to cover a few things. First, we'll do a brief overview of Wave. Second, we'll have a test gear tip of the day, so that's a clip that we've pre-prepared. After that, Erin will come out and show us some of her favorite capabilities on the brand new 4-channel 1000X series scope that was just released. When that's finished, we will draw today's winners, something I'm super excited about, and I'm sure you are too. And then we'll wrap up with some QA from myself and our panel. For the panel, like I said, we've borrowed some folks from the ASIC design team, from the Scopes dev team, and Brig AC, who you might recognize from the Double E's Talk Tech podcast early days. And then, of course, crowd favorite Kenny Johnson is also here. So again, put your questions in chat. It's being monitored, and we'll collect those questions for you at the end. If you have Wave sweepstakes questions, check out the FAQs page in the description and on the Wave website. So what is Wave all about? It's really our way of rolling out the red carpet for you, and at its core, Wave is designed to equip you to get better at what you're already doing. The first part of that is the giveaway, and last year we gave away big bundles of gear to just a few people, but you, the community, spoke up and said that you wanted more smaller prizes, and we were happy to oblige. So this year, we're giving away prizes to over 100 people. Every weekday, we're giving away one 200 megahertz. Every weekday between March 1st and March 15th, we're giving away one DSOX 1204G with a BenchView license. We're giving away a standalone BenchView license that has all the software options and goodies. We're giving away 2 of these U1233A 3.5-digit DMMs. They're nice little DMMs. They're super sturdy. We're also giving away 2 oscilloscope probe Tupacs. Turns out he's not dead. And in addition to those daily prizes, we're also giving away bigger prizes each day. There's a breakdown of those on the blog post link that we'll put a link for in the description. But they also include 1 gigahertz 3000 T-series scopes. Those are the touchscreen 3000 scopes. 120 megahertz dual output function generators, triple output power supplies, 7.5-digit benchtop DMMs, and some 4.5-digit, some of the U12, I don't remember the name off the top of my head, some of the nicer handheld DMMs that we're giving away. Today, we're going to give away an extra 4 of these 1000X series scopes. And as a grand prize on Friday, March 15th, we're also giving away a 6 gigahertz 6000X series scope and a 1-year license for an ESOF ADS simulation bundle. This is a software that we create that allows you to do advanced circuit and system modeling, allows you to model X parameters, and even do some like EMI and EMC modeling in virtual chambers. Super cool. You can come back to the Wave website each day and get 1 entry per day between now and March 15th, with the day resetting at 12 a.m. Mountain Standard Time, which is 7 a.m. UTC. Each entry that you submit is included in all the drawings, so you can come back each day to the Wave webpage to get an extra entry. But even if you only enter once, you'll still be entered in all of the future drawings for Wave 2019. We will draw winners and announce them each weekday on the Keysight Labs YouTube channel, so thanks for watching. And that video will also be embedded on the Wave homepage, so you can kind of pick your poison where you want to watch there. Each day's video will have a short test gear tip that the teams put together. The first one today looks at analyzing the frequency response of a system using an oscilloscope. So Erin put that together. Let's take a look.
If you're working with any sort of amplifier, filter, or power supply, You'll have to analyze how your device responds to various input frequencies. There are many cases where you might find certain input frequencies cause your device to malfunction, which of course needs to be resolved before the device is in the hands of a customer. The frequency response analysis capability, also known as FRA, allows you to analyze how your device is functioning in the form of a Bode plot. This enables you to view the gain and the phase of the input signal versus the output signal. The FRA application works by using the oscilloscope's built-in waveform generator to perform a frequency sweep at the input of your device. For this example, we're just going to test a very basic bandpass filter. So the waveform generator gets hooked up to the input of the device along with channel 1. And channel 2 should be connected to the output. This way the oscilloscope can compare channels 1 and channel 2 to calculate that gain and phase information. Now in the Analyze menu, we can navigate to FRA. And in the Setup and Apply menu, you can customize the settings like the sweep range and the number of points per decade. Once you have that all set up, you can just press the Run Analysis button. We can see channel 1 actually sweeping on screen as it should be, and the data plotting on the Bode plot in the background. So this blue trace represents the gain, and the red trace represents the phase. So with the Bode plot, we can see the frequency sweep range along the x-axis and the gain and phase data along the y-axis. And now you can analyze each of the data points with the markers on the chart, or you can also go into this table. You can also play around with the scaling if there's anything that you want to zoom in on to take a closer look at. If there were any errors in the device, we would most likely see a crazy spike or something that looks out of whack, in which case we will want to do some more digging into that specific frequency to figure out what it is that might be going on there. Luckily, my device responded appropriately during this test, so it looks like I'm ready to get approval from my manager to move on to the next testing phase. To learn more about how the FRA works and how it can benefit your testing, go check out my FRA Scopes University episode.
Thank you, Aaron, for putting that together. I don't know what was going on with the front of that clip, but I will say no one's ever accused you of being slow, so it looks like it picked back up, and we'll get that going. If you've been with us for a while, you'll recognize Aaron from some of the other videos on the channel, but you may not recognize the scope because the original 1000X series scopes, I'm going to grab one here, these things, they were a hit, but we kept getting feedback that there needed to be a 4-channel version, hence the new 4-channel 1000X scope we released in January. And since it's so new, I've asked Erin to come out and show off some of her favorite capabilities and parts of the scope.
Awesome. Thanks, Daniel. Hey, everyone. I'm so excited to be here to kick off Wave with you and show you the new 4-channel 1000X series oscilloscopes. Now, this series ranges from 50 megahertz all the way up to 200 megahertz, and they come in 2 or 4-channel models. Having the ability to use 4 channels at one time is critical for some applications, like when you need to perform 4-wire SPI testing, or if you have to ensure that multiple signals are transitioning at the correct time. And aside from its sleek new colors and adorable size, the best thing about the 1000X series is that it leverages the same proven technology that we use in our higher-end InfiniVision family, like the 3000T, the 4000X series, and the 6000X series. So this gives you professional-level measurements that you can trust. And this means that the 1000X has the same user interface and measurement performance as scopes costing 10 times as much. Entry level does not have to mean poor quality and performance. And just like the other InfiniVision oscilloscopes, the 1000X series is powered by the Keysight custom MegaZoom 4 ASIC processor. This custom chip ensures that you'll always see a quick response and the most accurate possible representation of your signal, even while you're performing complex analysis. And not only is the InfiniVision user interface simple and intuitive, but it also provides some huge bonus capabilities that can help get you up in testing even faster. The first is the built-in help system. All you have to do is hold down any of the front panel buttons for about 2 seconds, or any of these menu buttons over here, and a window will pop up with a little blurb explaining what that particular item is and what it can do. And sometimes it will even provide some helpful setup tips as well. The second bonus capability is the training signals. There are 17 different preloaded training signals in all of the 1000X series oscilloscopes, and actually all of the Infinivision family of oscilloscopes. So you can set these signals up by hooking your probe up to the demo pin down here and pressing help, and then training signals, and you can select from that list of training signals there. So these training signals are really helpful to learn the complex triggers of an oscilloscope, how to capture different types of measurements, and how to use some of the more advanced capabilities of an oscilloscope. There's also a free educator's training kit that goes along with those built-in training signals, and despite the name, it's not just for educators. It's really helpful for anyone that needs to learn the ins and outs of an oscilloscope. And not only are you getting all the benefits of a high-quality oscilloscope with the 1000X series, but you'll also get an integrated 20 megahertz function generator, a frequency response analyzer that performs Bode plotting, a 3-digit frequency counter, a patented 3-digit voltmeter, and a protocol analyzer. So you'll find some of the more advanced capabilities that are typically found on higher-priced oscilloscopes like hardware serial decoding, segmented memory, FFT, and mask testing. So the 1000X series allows you to go beyond the basics at an entry level and make measurements that you can count on. You can find more information about the 1000X series scopes and some hand-picked ebooks and white papers in the WAVE library, which Daniel's going to tell you all about.
Thanks, Aaron. Appreciate you coming out. Like Aaron mentioned, there's a link. There's a bunch of stuff in the WAVE library, which I'm going to show you here on my laptop. So we're going to pop over to my laptop screen in a second. If you have signed up for WAVE, that's the only way you can get to these libraries. And Richie, if you could pop over to my laptop screen, we're going to look and see what those actually look like. So when you registered for WAVE, you'll get to a page like this now that the event is live. The daily video will be here on the left side of the screen, and you'll be able to get your daily entry just by clicking a Enter Now button. Sometimes there's going to be an additional question here. That's just to help give us a little more information. But if you scroll down, if you've not registered, this is going to be grayed out. If you have registered, you can see a bunch of different links here. Let's go take a look at the oscilloscopes library. Here we've put together some hand-picked ebooks and app notes. A couple of these were actually written by Aaron, so you can go check those out. There's more information on the scopes themselves. And we have libraries for digital multimeters, function generators, waveform generators, power supplies, and I think there's also even one for DACs down here at the bottom. If you're using DACs, I'd be interested to see in chat how you are actually using those in your systems. So those are the WAVE libraries. I really recommend that you take about 15 minutes each day and just go through, pick a couple of those pieces that look interesting and read through them. The team here has worked really hard to put those together just for you, handpicked for WAVE. We also thought that this year we would pull together some of the older tip videos from the previous few years of WAVE and Scope Month, take a little walk through memory lane. So today we're going to have a bonus tip and look at how to increase the dynamic range of your signal analyzer measurements.
Hey everyone, my name is Nick Ben, and if you're measuring low-level signals and you need more dynamic range from your signal analyzer, how can you get it? One tool in your dynamic range toolkit is your resolution bandwidth setting. The RBW setting is a fundamental analysis parameter that's especially important when the goal is to separate crucial spectral components and set the noise floor such that you can more easily distinguish signals of interest from the noise contributed by the analyzer or device under test. Let's take a look. Let's assume we're looking for a low-level signal, such as a low-level spur. On the screen, we have an apparent minus 88 dBm signal at a frequency of 2.01 gigahertz, and we are sweeping with a resolution bandwidth of 100 kilohertz. We just barely see the spur here rising a bit above the noise floor, which is minus 88 dBm. An analyzer's self-generated noise limits its ability to measure low-level signals. In fact, a CW signal at the exact level as the noise floor of the analyzer results in plus 2.1 dB in error. Now, I'll use trace view to save this trace and I'll start a new measurement. In this case, I'll reduce the resolution bandwidth to 10 kilohertz. Now, we can clearly see this low-level spur. We gained 10 dB of dano by reducing the resolution bandwidth from 100 kilohertz to 10 kilohertz. And with this extra dynamic range, we can see so much more about our signal. For more information on optimizing resolution bandwidth, check out the application note Signal Analysis Fundamentals that discusses optimizing noise floor, resolution bandwidth, and more.
So if you have any test gear tips that you'd like to see in future days, put them in the comments. And I also want to point out the R&D engineers are a little uncomfortable in the room because Aaron left the scope untriggered. So I'm going to go ahead and fix that. And now you've made it. It is time to give away some gear. And I'm going to draw 10 winners today. That's going to be 5 of these 1204 1000X series scopes, 2 of these handheld DMMs, 2 of the probe 2-packs, and 1 Benchview license. So here are today's winner. And while that is polling, there we go. And while that's polling names, I want to make a quick comment that the system we're using to pick winners is sufficiently random, but I'm not going to go into any more detail than that. We get a lot of questions about that every year. I also personally vet each winner to make sure there are no signs of people trying to gain an unfair advantage. I'm going to go look through that and make sure all these winners are squeaky clean. So today's winners, the first 5 are going to win a DSLX 1204G scope with the options Christian Koch, Ellis Newkirk, Shivam Gaj, Paul Ramos, and Hyungjib Kim. Congratulations, you won a scope. We have 5 more winners today. The winners of the U1233As are going to be Patrick Ainge and Malt Mager. The Benchview license is going to go to Junghua Ha, and the probes are going to go to Osborne Christensen and Alex Mora. Congratulations to our winners. We'll be in touch with you within 48 hours via email. So if you think you won, we've had some issues in previous years where enough people enter that some of the winners have the same name as some of the people who didn't win. So look in your inbox in the next 48 hours. You will hear back from us if you're a winner. And that's the end of the formal live stream. So it's time to move to our panel Q&A. So let's bring out some microphones. If my panel can come on out, we're going to clear this off, and we have some panel mics coming. Thank you so much for watching, and while we're setting up, make sure you're subscribed to the Keysight Labs YouTube channel. You can check out the Double E's Talk Tech Electrical Engineering podcast panel. You guys can go ahead and pull out your chairs, make yourselves comfortable. I'm going to pull up the chat so that I can see your questions come in and kind of moderate this. And then while this is happening, let's see if we have any other questions from the chat from this video. So if you have questions for our panel, let's go ahead and pull those out. We have a microphone right in Kenny's face, so I'm going to do that. How's that look?
Yeah, be careful.
Perfect. I know. Yeah, you got to watch out giving Kenny a microphone because he has some. I think our favorite scope tip still of all time was from the first scope month where you showed us how to use like a $15,000 active probe to clean out the charging port of your smartphone.
Yep.
Yeah, that was a good one.
Yep.
Okay, let me pull up the chat for the stream. If someone could send me a link, because I only have the old link to the stream. So could you each introduce yourselves and tell us a little bit about what you do? And then Connor, we'll start with you.
Sure.
Go ahead.
Oh,
Don't worry
sorry,
about
I'm waiting for the camera. Okay. Not a seasoned video professional here. My name is Connor McKay. I am on the digital ASIC design team here at Keysight. So I work on the team that designs chips like the MegaZoom 4. I've been working at Keysight for about 5 years. We work on chips for scopes, chips for spectrum analyzers, signal sources, all sorts of things like that.
Awesome. Thanks.
Cool. Hey, so my name is Kenny Johnson, former R&D engineer for about 30 years. They figured out that I own a belt and use hair products, so they put me in marketing the last couple of years. And so my role really is kind of a solution architect these days.
So my name is Chris Grove. I was a software engineer, still am, for the Infinivision and Infinium scopes. I've been on the Infinivision team for about 10 years now.
Awesome.
Hi, my name is Brig Acey. I'm the Director of Strategic Planning for Internet Infrastructure. We just look at scopes, spectrum analyzers, you name it. We pretty much do any kind of planning around it. So,
awesome. So the Hacksaw, with all the fun spellings, asked a question: what are your top 5 bench test equipment? Like, if you had to pick 5 pieces of equipment and you were stranded on a desert island and you just wanted them to have them, maybe they weren't going to rescue you, what would they be? We'll start with Brig. You guys can think about it. Yeah. Brig's our marketing guy.
Yeah.
So Oh, so my top 5 would be the scope.
Okay.
As number 1, it's really
to that.
general,
Yes.
really general purpose. Number 2 would be spectrum analyzer. Again, I like the general purpose type tools. Right behind it, network analyzer. To be able to go, there's a lot of utility. It's very, you can do a lot of different things with the network analyzer. Not to be outdone, any of the software that lies on those instruments would probably be my number 4 because there's a lot of automation, things like that are coming in that we're doing. And then my 5th one would just be the simple multimeter to be able to go take really easy measurements. It's kind of the do everything with kind of instrument.
Not bad choice.
Chris?
I'm a software person.
Okay. What about software tools? Top 3 software tools.
So I will say that, all right. So my favorite code editor right now is Visual Studio Code. I use it on Linux, Windows, and Macintosh. It rocks. It's come a long way. My favorite compiler is C++, so probably go ahead along with that with CMake in order to pull everything together.
Awesome. Kenny?
Hey, okay, so, I like Briggs' list, except he didn't include probes. You gotta have probes there, dude. Being a former probe designer, you gotta have some probes on that stuff.
Everything I do is cabled.
Yeah, okay. A couple of the other things, though, that I like is, might get overlooked, but nice bench supply, especially like some of the SMUs, the source measurement units, those things are crazy good. And then, of course, a good GP scope. I don't know
GP meaning general purpose.
Yeah, general purpose. Yeah. Gotta have the multimeter. I like actually some battery powered gear myself and everything. So that's the multimeter thing. The probes, and I would say for me a network analyzer versus the spectrum analyzer, just because I get enough out of the FFT on the scope and everything. So that's it for me.
Calm down, all you signal analyzer people. Yeah, sorry. Deep breaths. Connor.
Well, if we're going with the desert island theme, I think I'm going to go with some sort of signal source and possibly a microwave test head so that I can hopefully get rescued from the island.
Good call. Good call.
Yeah.
Okay, but that leaves 3 others.
3 others. Okay, then I'm going to, as a digital designer, I actually use more programming tools than actual benchtop test equipment. So I'm going to go with my favorite text editor, Sublime Text, my favorite scripting language, Ruby, and let's just say Bash.
Because why not, right? You mentioned tools. One of the questions that came in on the design side for you was, do you use VHDL or Verilog, and do you get a choice? Or
At Keysight, the choice between VHDL and Verilog is generally a geographic one. Here in the US, we primarily use Verilog. We also have teams elsewhere in the world that use VHDL for their parts of the design. So a lot of times our chips are kind of a hybrid. Some parts are VHDL and some parts are Verilog, depending on where they're designed.
Cool. This one came up, and I might throw this at Kenny or Chris, whoever wants to answer. Could you talk through a method of doing frequency response analysis on a scope that doesn't have an FRA app? And if this one you don't want to answer, I can take that one.
I cannot answer.
Okay, fair enough.
So
How would you do it? I'm going to put you on the spot, Kenny.
What are you looking for now? I don't.
How would you measure frequency response on something without an FRA app? And there are some tricks out there.
First thing we do, like when I'm working on a probe and everything, is actually just hit it with a very, very fast edge, just looking at the step response. And I can learn a lot from that right there and everything. So that's the first place I go. And then, a lot of other times too, it's really weird with our probes because they're not necessarily 50 ohm systems, so you can't go use like a VNA or something to actually sweep them. You have to, almost have to use like a poor man's VNA with like function generator and weird little like test fixture so you get the right source impedance and input impedance for the scope and everything, or for the probe. But most of the time it's really looking at step response is what I do.
Okay. Yeah, step response, that's a great answer. There's also a couple of videos out there. I think Dave Jones has one, and then not Andreas Spies, but he has a great channel too. Julian Illett has like a synthesizer project he's been working on over the years, like a vocoder thing. And they do some like persistence settings with a frequency sweep, and you can kind of almost curve it out as the frequency sweeps up. You can watch. It's, like you said, kind of a poor man's FRA version, but you can check out those 2 channels. We'll maybe try to find some links, but if you search for it, it'll definitely show up. Here are a couple other questions. Software engineer on the panel. What, Chris? What? I'm just going to call you the software engineer.
That's going to be your new name now.
Yes.
Software engineer on the panel.
What programming languages do you use?
So Infinivision is developed 100% in C++. Infinium is actually a mix of C++ and C Sharp.
Okay.
I also, because I'm the system integrator for doing platform development, I also use Python, Batch, JavaScript, and Bash, depending
Okay.
on whether or not I'm targeting Linux or Windows.
Great. Yeah, Chris is kind of our lifesaver in the building, so I know she always gets a little nervous when I come into her queue. Can a Keysight scope ASIC mine Bitcoin? Yes or no?
No.
That's
The digital chip designer says no. That's a 0.
I'm afraid that's a very specific application we don't include in our normal feature sets.
No one like snuck it in on the weekends.
I'm not saying
I'll
there's-
admit the
are
idea
you
has
saying there's
occurred
no
to me,
chance
but
of
no.
is that a firm no or?
I know.
So MegaZoom 5, no?
No.
Mega Bitcoin 5. Okay. What is the maximum, I don't know if we know an answer, what is the maximum sine wave frequency that we're able to generate in this building or at Keysight? We normally, like you throw a fast edge, I think is where the question's going. You use a pulse generator or?
Yeah. But for the sine wave kind of stuff, what are we doing on the UXR?
So what we're doing on the UXR is we actually use a laser and modulate the laser to get to a sine wave over 100 gigahertz. We do have some pulse gens though that'll generate sine waves well over 50, 70 gigahertz.
So can you talk about that a little bit? That's news to me.
Yeah, so essentially,
Lasers, right?
yeah, so what we do for our UXR, which is our highest end scope, 110 gigahertz, we take a NIST calibrated laser, run it, and I'm going to break down really quickly in here. This is not my super area of expertise. So for those of you that are listening that are laser experts, please do not count this as gospel. So we take in, we put a laser in, again, basically adjust the laser to do a sine wave, and I break down at this point, and that's how we get to the 110 gigahertz on the sine wave.
Okay, cool.
But we had to do it just because there wasn't equipment that did 110 plus gigahertz on the sine wave, so we had to figure out a way to do it, and NIST was nice enough to provide a laser that would allow us to get there.
Interesting. It's like, how do you test a 110 gigahertz source if you can't I guess you do it with a RF piece of equipment. What do typical project teams for test equipment look like? So I'm going to make this a little broader. We have a few different, representatives from distinct teams, and there's a lot of cross-functionality where, Connor's helping create chips, and Chris and Kenny historically are helping to integrate them, and then Brig is helping plan them and make sure that, they get out the door. So can you speak to that cross-functionality between teams? Brig, start with you.
All right, I'll go ahead. I'll start. So it depends on what kind of project that you're doing. So let's take, again, I'll gravitate towards the UXR. It was just introduced. It was a really expensive, really big project, right? And so from that standpoint, you start with custom chips. And so you have a group of, let's say, 15 to 20 people working just on the custom ASICs that are inside the chip. So that's a group. You have another group that's doing wire bonding and the packaging. What does that look like? Another group of 10 to 15 people. You have all the software on the Infinium. And again, that's another really big group of people. You have the people that are laying out the boards, similar sizes. And so that's just from the R&D side as far as how many people do you have working on the project. And then couple that, you have your marketing guys that are looking to see how do we want to launch this? What do we want our message to be? A fairly large group there. And then, not to be forgotten, though, you also need people that can run, the tools to make the scope orderable. And so you have what we call it's NPI or new product introduction, but that's a whole nother group of people that their whole job is bringing that scope to market internally. And then you have the marketing guys that are bringing that scope externally. You have planning. What I'm saying is this is a very large team that works on these scopes to bring them to market.
Well
Awesome.
done, Brig.
Thanks.
Well done.
Does anyone want to add to that?
I'll just add that we also have order fulfillment, so the people who actually need to manufacture
Yep.
and test and actually make sure that we actually are able to ship
Absolutely.
that instrument as well. And so that's usually a large team. both that sit side by side with R&D and then also with our manufacturing.
Don't forget, you got to have a good probe with that, though.
We just took a tour of the hardware test center that's pretty much directly below this building, all their chambers and flex testers and shake tables and stuff. So maybe we'll splice in some clips from that for the rest of Scope Month, or call it Scope Month for the rest of Wave. That could be pretty fun. Other questions? I know there's not a specific answer for this. How many engineering revisions do you go through until you're ready to actually release a product? And maybe you could answer it on the chip side, and as a digital guy, you say one and move on. But I think, can we talk through like the design process and the challenges that are faced?
Yeah, sure. So for at least digital ASIC design, which is primarily what I'm familiar with, there's kind of a few different stages that a chip goes through. You start off with conception, designing kind of the applications and the requirements for the chip. You start actually developing the code for it and going through that. And eventually you reach a stage that we call INL, which is the initial netlist release. And that is the point at which you say, the chip probably isn't functionally complete. It probably wouldn't work, but we at least have representative sizes of all the different functional blocks. We know roughly how big it will be. We know generally how much power it's going to take, what the features are going to be in it. That happens fairly early on in the process. Then you continue to develop the chip, you continue to work on it. You reach, the next stage is trial netlist, or trial netlist release, which is where the chip now is functionally complete, is hopefully correct. There may still be bugs and verification continues past that point, but from there you actually take the ASIC and you run it through the entire back-end process, which means you start from the RTL, the Verilog or VHDL, you synthesize the design, they do layout, design rule checking, all this stuff, and they actually produce a trial version of the tape-out net list that would be sent off to the fab. So they basically pre-run the entire process for going from the RTL to the actual released version. And then after that process finishes, they incorporate any last fixes that are coming in as part of the design process, and then they go to production netlist, or PNL, where we actually take the final design, synthesize it, check it, release it, and then that goes off to the fab. They produce it. 6 to 9 months later, it comes back, and then you test it and hope you don't have a big resistor. A very expensive resistor.
Good answer. What about, okay, so very thorough and excellent answer on the chip side. What about more on the product side?
So one of the things I was going to plug into is a lot of times during the design phases, the software team is engaging with the ASIC team, talking about the register lists and functionality that we need in order to support the different functions, instrument functionality that the ASIC is going to handle for us. And a lot of times we're actually going to write software that's going to interact with the simulation so we can help debug some of that functionality early on and start work on our drivers to control the ASIC.
Awesome.
Wow.
Cool. Those were all great answers. What type of role would a mechanical engineer play in the development of electrical test and measurement equipment?
So I'm the token ME. I got out of school with mechanical engineering degree, and I've been working on these. It started off doing chambers and, the plugins. Did a big frame and all the computational fluid dynamics for the cooling and all the RFI and the structural stuff, and then got into probes. And probes are a pretty cool little electromechanical system and everything that they're tightly coupled because you're trying to make things so small. Every change that you make to it mechanically affects it electrically, and likewise electrically and mechanically. And so through about 25 years of osmosis and everything, I got to the point that I was designing probes too. And not just the mechanical, but the electrical and everything. So, but there's a ton of opportunities here, and it's a great place actually to make a living as a mechanical engineer and everything because of the tools available to us. Heck, if you're working in Colorado Springs, that's a great place to live. If you're like the outdoors and everything. So yeah, I've enjoyed it. Worked out good for me.
Awesome. And there's actually a few mechanical engineers in the building that
There's a ton.
I like to joke that they just work on heat management, but
Yeah,
they, they don't think that's very funny.
a lot of the process engineers and things like that are mechanical engineers. Yeah, there's Probably about 20% of the engineers on site are mechanical.
Okay.
I'm always amazed at how excited they get about the mechanical engineering of a box. You look at it, you're like, hey, it's a box.
Yeah.
No, you don't understand. Look at, we got little,
Got the subtleties.
exactly,
Yeah,
the subtleties of it.
But
I'm always impressed by that.
It's extremely important because I've heard tales of in an oscilloscope, if you have a misplaced fan which turns on at the wrong time, you get cooling of a certain component that can actually affect your signal integrity coming into the scope. And so mechanical engineering design actually does affect the electrical performance of the device.
You know, I'll just throw this out. You were talking about the 110 gigahertz UXR. So the first scope I worked on in R&D, I did the plug-in modular part for our back then real-time scopes actually had plugins, and that same frame and plug-in architecture and everything is still used today in the sampling scopes. But back then it was a 1 gigahertz box, and we couldn't decide if it was gigahertz or gigahertz. And since then, now we're at like 110, and that's real-time. That just blows my mind.
Awesome. It's interesting looking through all documentation every once in a while. Some of the words used to describe something have changed. And an example now is like in a DMM, the number of counts versus the number of digits. Like, which one is it? And I think we're in a shift there. Can any of you describe any amazing phenomenon you came across while designing or exploring, proof of concept for a project? Anything that was like surprised you, or unexpected roadblocks maybe?
Okay, a probe story. So I was working on a current probe. You know, one of the problems with all of today's handheld and battery-powered devices is chasing around the milliamps and the microamps and stuff like that. And so they wanted a scope probe that could measure very, very low down to nanoamp kind of currents. And so all the stuff that existed today just can't do that. And so I got to working on some things, and I was working with like flux gate magnetometers. And anyways, I was trying to go, long story short, was I took it down to where I made this very cool magnetic field sensor that was sensitive to the current flowing through a trace down to the microamp and nanoamp range. But it turns out I was swamped out by the Earth's magnetic field. And so what I really had was, instead of a really slick probe, was a great compass.
Awesome. That's okay. Couple quick more questions, then we're going to wrap up. This is more of an application question, probably for you, Kenny. What if I replace, or Brig too, because you're talking about cabled. What if I replace probes with other wiring, like a BNC or a 50 ohm cable? Like, is that a thing that people can do, and are there trade-offs for that?
Well, most of the time, so with most of the systems, so the input to the scope is 50 ohms. And so most of the time what's happening is you're actually like terminating the bus or whatever into the scope. Probes, you actually don't terminate it, you're observing it as it goes by. And so we're not, absorbing or anything like that. And it's a different technique then. When you're observing it going by, you need to be really high impedance so you don't steal any of the signal off there and distort it. But typically when you're cabling it into the scope and everything, it's all 50 ohm environments, so they're really not interchangeable. It's different applications.
Yeah, just one little minor add to that too. So one of the nice things with the probes is, Keysight, or name your competitor, we do all the compensation for the probe loss, and that's all taken care of as far as the signaling goes. The second you go cabled, those cables aren't perfect, and so you have loss and different things that are in that cable. So you just need to manage that when you're doing, especially as you get into really high frequency type measurements, the cable loss can be a serious impact to your measurement
over a very
that
short distance,
we as test and measurement vendors have no idea what you're connecting to the, to the instrument, and that's across any instrument. And so that's advantage of probe is we know exactly what's connected.
Yeah.
Advantage to cable is it's simple, but we have no idea what's going on there or what's connected to the front end.
That's a great point.
Awesome. That's a great way to end it. Thank you all so much for coming out, and thank you everybody for watching and joining us. Make sure to tune in each weekday between March 1st and March 15th. We're going to have a daily video with a test tip and a drawing for more test gear. And make sure to subscribe to the Keysight Labs channel. Daniel Bogdanoff, thanks for watching, and we will see you next time.